Hello and welcome back to ZIM Tutorials for Adobe Animate. I'm Dr. Abstract, and in this tutorial we're going to take a look at ZIM Physics. So let's go to the ZIM site now at zimjs.com. In ZIM 10 we introduced integrated physics, so we brought physics right into ZIM rather than an external library, although we still do use external library of CreateJS, of course, but for physics it is Box 2D, which is what Angry Birds was made with. Okay, so I mean, we've done lots of examples with physics, and there's some nice easy ones to look at. This game is made with physics. That's not a nice easy one. That's quite a complex one. So the two games in here, this one right here, Alone Droid and Alone Droid 2, that's sort of a side scroller type thing with physics, and this is, well, also something similar to a side scroller as well. Both those are quite complicated in physics, although ZIM makes them simpler. Let's see, do we have any? This is physics, so these hairs are all sort of brought together. This is a game to try and keep the hair on Noodle's head as it falls off. That's kind of fun. I think, no, .gone wasn't. There was another one like that where we drop a ball down pegs, and that was all made with physics as well. Here's the physics section, though. So up in the top of the game section, there's more. And in the more, it talks about hit tests. So we just did a tutorial on hit tests, on sprites. We've done tutorial on sprites. There's some information on physics. We also have other modules, such as the game module, leaderboard, an isometric board. We can work with 3JS and sockets. So there's other modules that will help with games as well. But up here, or this one right here, is physics. And there's an add physics method that goes to what? Okay. Anyway, back here, there's under examples. If we look at the collections, there's the ZIM 10 right here, ZIM 10. Oh, I saw the physics collection directly there. There's physics right there. So I'm going to say we integrated physics in ZIM 10. So you can find it where easy physics. Okay, so that's one place, or as mentioned right here is physics. And this is our intro to the integrated ZIM 10 physics, where we've got a bunch of balls falling, quite easy to do, and a few physics things here. So the way physics works are they can move, which means they're dynamic, or they can be not dynamic, which means they're stationary. And you can toggle between those. So here's some examples of what we can do with ZIM Physics. If we contact, so these two, it's a little bit different than a hit test, because when it bounces, it's hardly even a hit test, is it? But the physics will know when it changes direction. So we use contact when we're using physics rather than a ZIM hit test. So that tells us if we contact, note that we can pick that up and drag it, and we can pick this up and drag it too, but they're slightly different. I can hardly throw that one. It spins, yes, it spins, but so it has angular damping is less, so there's not much angular damping, but there's a lot of linear damping. This one has less linear damping. That's how much it slows down. So you can set those two things. There's also friction. And right now also we don't have gravity here, so this is a top view version of this. All right, let's go try another one here. Oh, sorry, it looks like we had to go back there. Here are beads. Beads are using linkage, so you can link the physics objects together and make things like beads. Here's a game of keep it up. And what we're doing is when we press, we're applying a force to that. And note that the force is the center of the ball is here. We're applying the force at whatever side we're pressing it, and that's what causes it to spin if we go in the side. If we press it right in the middle, it goes more straight up. Okay, so the idea is you can play keep up, and we know when it hits the bottom because we're using contact there. One way to cheat is to sort of pick this thing up and try and, there we go, 1, 2, 3. So use the water bottle to hold it. All right, so back to physics. The last example is using the, we can run physics like with an arrow. So this is like the motion controller, but it's specifically built into, it's called control, built into physics. And we're also using the frame.follow. So you see what's happening there is, actually it's physics.follow, sorry. The frame.follow does the same thing with the overall stage. It makes the whole stage move around while you move within it. But here it's we made this in physics, and it was so cool in physics that we decided we would bring it into frame. So there we've also got contact. You see how we're contacting, and the idea behind this little mini game here is to turn all those things off. Unfortunately, if you hit them again, it turns it back on again. All right, and when you're done, it will tell you, and it's got a timer going. So that's the idea behind this one. So we're using physics contact, we're using the control, and we're using the physics follow, which sets up the physics object to follow. Again, no gravity falling down. But on the very first one, we had gravity falling down. So here's gravity going down. You also have something called buoyancy. So we had some other examples of physics here under examples, which were earlier versions of physics. If we look inside of the ZIM bits here, let's see if I can find them. There was soup, for instance. So it looks like a bowl of soup. There it is. Quite cute. There's stuff. There's buoyancy. So the stuff inside here kind of floats like that. And you can add more of these. Push them out. Okay. Hold down a key and get lots of them. Oh my goodness. So isn't that nice? All right. That's enough looking around, I suppose. And let's go into Adobe Animate and see how we can apply physics there. We will make a new preset. Not a new preset, but a file from a preset. Very high, create. And when we bring in, we had been bringing in a profile here, like so. This profile, we've been importing it. That's the one we made way back at the beginning. But that profile, all it does is two things. One, it brings in the ZIM shim here. So if we import new, ZIM shim. But take a look. There's ZIM shim physics. So that's the one we want to bring in this time, a different ZIM shim. So I'm going to go, yeah, we want the physics one. And that brings in box2D and the ZIM physics helper library. Back here under basics, we can still center our stage and stuff. That's what we did before, and hit OK. So now we've got physics. Let me just pop out to ZIM for just a sec here. Under the code section, if we look at libraries, so here's code, and we pop on down to libraries, here are those extra libraries we were talking about, socket, game, ZIM 10 physics. So this is physics showing you the stuff there. There's older physics examples, 3JS, Pizzazz, and data stuff. Another place that you can find this is if you go under the docs here. So under the docs at the top, here are the helper libraries. So there's socket, game, physics. So that's the ZIM physics. And then ZIM also works, as it says here, with box2D. So for physics to work, you need the ZIM physics helper module, and you need the box2D. Under the helpers, right here, helpers, there's the game module, the 3JS, the socket, and the cam, and Pizzazz, but physics is missing. That's because physics is now built in to ZIM, as mentioned. So we've got it right in the main doc with this add physics. And so here's the documentation for adding the physics. Here's the documentation for removing the physics. And then here's the physics class itself, which has basically all of the information that you need. It's kind of a combination of everything. So there's add physics, which is a special way to add the physics, but this is the physics class, all of the documentation for that. Okay, so it's quite complete there along with your various examples. We'll leave this open here. We might need to come back to it. So F9 back in Adobe Animate, and we will make our little message up here. This is ZIM, and we are on number 20. Ooh, I can't remember. Let's see if I can find it somewhere. 27. 27. Oh, just snuck physics in here, huh? Physics. I think we've seen just a touch of physics before, and we saw how easy that was, but if I remember correctly, but I could be wrong. So let's see how easy it is indeed. New circle, dot center, dot add physics. Ready? Oh, I have to save up the file as something. So file, save as, and not 26 hit test, but rather 27 physics. Physics. Okay, control enter. Ah, you missed it. Yeah, missed it. Refresh, there it is centered, falls to the ground. Okay, not very bouncy. So in here, we can specify how bouncy it is. I'll go directly to that just as an example. Bounciness. Colon, how about a 0.8? So that's fairly bouncy. 1 is about as bouncy as you want. Once you get beyond 1, it starts adding bounciness to it. So you drop the ball and it'll bounce higher than it actually falls. So anyway, here's a bouncier ball. Boingada, 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 boingada. Okay. And we can't at the moment pick that ball up unless we add physics. So as soon as we want to start doing other things with physics, it's probably best to start off with const physics is equal to a new physics. So in other words, if there's no physics object already made, physics, right? If there's no physics object already made, one will be created automatically, and you could get reference to that physics object, or the overall physics object, by asking for circle.physics. But probably best to start the other way, start with physics. That way you can set up your gravity and your boundaries and stuff like that if you want here, and a few other things. And then when we add physics, it will add to the current physics object. So great. If we want to drag, it's a little bit different. We say physics.drag. So what that will do is not really dragging, because in physics, you don't want to be, you don't want to act like God. You don't want to just put this thing at this place, put this thing here, drag this around with the ZIM drag, for instance, because you should let the physics object or the physics engine work out where stuff is. And so when we actually pick something up, how we pick it up is with called a mouse joint. So it's a joint. It joins it to where the mouse is and then tries to drag it around. And so it's a little bit different. Not only that, if you put a drag on physics, anything that is dynamic can be dragged. But you can specify certain ones to either drag or certain ones to not drag, etc. But this will just drag anything that is dynamic. Let's get rid of the bounciness just for now. The very first thing is whether it's dynamic or not. But let's try the drag out. There we go. I don't see it. Physics.drag, center, new. Oh, I did that again. So when I type in animate, I type physics lowercase and put a capital there. It bops it down to lowercase. So there's our ball. It just fell to the bottom. But now I can pick it up with that mouse joint. So you see how the mouse joint kind of holds it against the edge there as well? So that's a mouse joint. And let's try making something solid. How about a new rectangle? Solid, sorry, static or like not dynamic. So a new rectangle, we'll make this 200 wide and 50 high, maybe 30 high. Well, let's make it a different color, purple. And we will dot center this, or well, let's try the dot pose in the center. We haven't seen that too much. So one thing is we can center it and then move it, but we can pose it at 0, 0 in the center and in the center. But let's move it down a little bit. So this one moves it down a bit. How about 100? So this is saying 0 the middle of it, but move it down from the center at 100. Okay, if we just did that, we'd have a purple rectangle and the ball just fell through the purple rectangle, want to see? Okay, because we didn't yet add physics to it. So now, once we pose it, so remember how I said it's not a good idea to position things that are in physics. We want to let the physics do it. We can position it first and then add physics. we're going to see something that's a little broken looking. So here we go to add physics to the purple thing, and we'll see that it's not quite right. So we've added physics. Wait a sec, why did it even stay there? Add physics. It should have fallen, first of all, so something's a little bit off. Circle dot add physics, posed in the center, add physics, and it didn't fall to the ground, did it? Did I spell it right? Physics, yeah. Any error? F12. Huh. What's going on, Mr. Rectangle? New rectangle, purple, position, and add physics. We got our physics, we got a new circle, we got our new rectangle. I don't know why that didn't fall to the ground. I can't see. Let's try a center for a sec. They both fell to the ground. Great, they're both draggable. But what the heck happened with the pose? 0, 0, commas from the center. From the center. And we'll make it 100 down. Oh, sorry, 100 down from the center. Ah, I must have just not have saved it or something like that. So, and they're both falling. But, okay, so they're both falling, but there's still a difference. You see this? It seems broken or wrong. It's not really working properly at all. It's way up in the air. It's like, what the heck is going on here? Well, what's going on there is all of the physics bodies need to be center regged. So let's set the dot reg to the center, like so. Or indeed, if we wanted to just center it, the circle is by default center reg, so we're okay. But the rectangle is top left corner. So we put the registration point to center, basically. That's all we need to do. Now they're both falling properly and in the right place. There they are falling. Here's this one. Here's this one. We're throwing it around. And wow. Okay, isn't that wonderful? But just remember to center reg your physics objects. However, I wanted to make this one not move. So what we do is false here stands for dynamic false. So this is dynamic false, like that. And what that means is it won't move. So now we get it dynamic false. It's not moving. And look at what we got. We got a ramp. Well, actually, we could make a better ramp. You ready? Dot rote 45. Control Enter. Oh, wow. That's a bit of much of a ramp, isn't it? And note that it's not very bouncy. So once again, we can increase the bouncy. Do you remember how we did that? So on our circle, there's our physics. We can go bounciness, colon, say 0.8. And now I can see it bouncing away there. See, it might be too much. Look at it bounce. Seems to start bounce for quite some time. Ready? Boink. Ah, great. Oh, so you can imagine a game of basketball or whatever. But that's picking things up. So how do you then apply forces? I mean, there's lots of things that you can make with that. As a matter of fact, let's just do a small adjust here. Closing down some of these previous ones. Let's just do a small adjust and make it so that the physics has no gravity. Gravity is the first parameter. So now it's like a top view. And we can throw this around. Boingada, boingada. Okay, it's a top view, and all of a sudden you get, oh, you can just start thinking pinball and pool and all that kind of stuff as well. So remember, there's a setting that says how slow or how much that's going to damp. That's called linear damping. So linear damping, and you've also got angular damping. We can't see that spinning, but it is actually turning. For instance, if I say const circle is equal to that new circle, and then I say const, well, I don't need to do that. I can just say new circle, and we will say 20 comma green, well, maybe a bit smaller, 10 comma green, dot center on the circle. Dot move. So here's relative movement. I could have posed it like this in the center in the circle, handled it like that, but I'm going to just relative move this over, say 50. Okay. Center on the circle move. It's green, and I'm getting an error at the moment. So new circle, const circles. Oh, made it a lowercase one on me again. Come on. Okay, so that moved it a bit too much, so we'll move it 30, and we get this. So now we have a little circle. Hey, it's an olive. We have a little circle on there, and you can see that as we move it around, well, it would have been maybe better if I dropped it, but as we move around, that is actually spinning like that, and you can say how much that's going to spin. So you can set the radial damping as well. Is that what it's called? Linear damping and radial damping. I think that's it. Well, we can look up in the docs. Remember, we've got our docs here. So under physics, well, we probably want that other add physics. I mean, this would have it too, add physics. It's got all of the add physics in it, but it's got so much more that it's sort of hard to find. So under parameters here, here they are. And we've got the linear and angular. Okay, so that's it. Just linear and angular, not radial. So linear will handle the linear damping, and angular will handle the angular damping. Density is how heavy it is, thick it is, so that will affect friction, it'll affect bounciness, it'll affect buoyancy as well. You can change the shape of it. So often we have a ball, like a soccer ball, and we bring in a PNG of the soccer ball, and yet PNGs are square. So all you need to do is say shape circle, and then that square picture will act like it's a circle. You can contract that. So contract also works in the negative to expand. So if you wanted to say run a ball along a track, like I don't know, a railroad track or something, you want the ball to come down lower than the track, you can contract the ball and it will appear to, you know, roll on the track a little bit better. This mass bits and category bits, they're quite complex, but this is how one object will collide with another. So by default, they'll just always collide. All these objects will collide, but you can make certain ones collide with other ones, but not with yet other ones, okay? And that's with this mask bits and category bits. So have a read through that if you need to. Restitution is what bounciness used to be called. It was such a weird word that we changed it to bounciness. So you can ignore that. All right, isn't that neat? So that's physics, but what I was going to show you is applying force to physics. So say we wanted to, instead of doing the drag bit here, do something that we teach the kids how to do then even. So I'm going to go to the ZIM site here, go into the bottom under kids, and let's take a look now at the bugs right here. So there's putting a bug along a path, just moving a basic bug, bugs with sugar, chasing around sugar, and here is the bouncing bugs example. So imagine, this is us teaching kids about physics. So that's the first one, just to get that. In level 2, we do physics.follow. Look at that. We can have it like go up and follow where the mouse is. Woo! We can make that stop there before it hits the edge. And look, also contact to find out if we got a score. Score! All right, woohoo! Level 3, this is what I'm talking about right here. We have a few things that we can move around. Well, we can't move that one. But watch, if I press anywhere in this ring, it shoots the bug. Boing! And that bug will shoot the other bug. Boing! Uh-oh, another bug came back. So the idea actually is we're trying to put those bugs back in the box. So we make bugs, but there we go. We got it back in the box. Boing. And note that I go under the box too, and then things come out. So that was with the contract in there. But this is what I want to show you right now is how can we apply a force. So we're not dragging that, we're shooting it. And that gives you, we did a code in 5 minutes with Angry Birds, how to pull back an Angry Bird and let it go. So Angry Birds was made with physics. You can check the code in 5 minutes series. Where you find that is on the ZIM site here. Under Learn, this is one place to find it. and there's the video series code in 5 minutes. And in there, it's Angry Birds. We actually made the basics of Angry Birds in 5 minutes, but then somebody asked for more, and so we added more in 5 minutes, and then more in 5 minutes, and more in 5 minutes. We got basically a complete Angry Birds game, relatively complete anyway, in about 20 minutes. So you can check that out. That's with physics. There's some other examples of easily using physics there as well. Then there's some longer ones in Explore, which probably would look through physics. All right, let's go back in though to Adobe Animate here and see how we can apply a force to an object. So right now we've made physics 0. The force would also work if you had gravity as well, and you could have cannon shooting, that kind of stuff. It's a lot of fun to do. But here we are top view, and we won't want to drag, so I'll comment that out. Oh, by the way, just before we do that, let me show you physics.debug. Okay, so this is what box 2D kind of looks like. What we're seeing here is the box 2D outlines of what box 2D thinks is happening. And so watch, when I drag this, watch what happens. This line right there is showing a joint. Whee! And so you can see that that's a little bit different than most dragging. So that's the joint. But isn't that cool? That's a debug mode, and sometimes it can help you. For instance, that's moving, moving, moving. When it stops moving, there, it's now not active anymore, so it's turned itself off. This one is a static one. Okay, cool. So I can show you some things and kind of help you with some things as well. That's the debug mode. But I'm going to comment both of these out, up, and let's move to applying a force. Right now, they're not going to move, but if I wanted to, I could put a timeout. Let's move down a bit, doesn't matter, but coming down here. Timeout, this is a ZIM timeout. It's like a JavaScript set timeout, except it works in reverse. So we're going to wait 2 seconds. First of all, it's in seconds, not milliseconds. And the time comes first, and then we call an arrow function. Much like we have an event. What kind of event is it? Call an arrow function. Loop. How many times do we want to loop? Call an arrow function. So we just flipped it. The JavaScript time set timeout, the time is after the function. We always forget to set the time because we're working on the function. So anyway, we just flipped it, and ZIM interval works the same way. And also we can handle ZIM v values. So these are those dynamic parameters in our timeouts. There's a few other cool things about them too, but we'll leave it at that. So there's timeout, and at this timeout, I'm going to apply a force to the circle. So here's the circle here. So after a timeout, we say circle dot, and we've got a couple types of forces. One is an impulse, and that's the one that we want to use if we want to like hit it. We use impulse. The other one, sort of confusingly, is just called force. So we might think it's force, but force acts over time. It's like gravity does. So we would put force in an interval or in a ticker or something like that to apply like a wind force or something like that. All right, we don't want to do that. We don't want a constant kind of force operating over time. So we want an impulse. Got that? And then we put in here how much in the x and how much in the y. So let's do an impulse of 100 in the x and 0 in the y, or we could have left that out. You ready? Let's see what happens. Oops, it already happened. I didn't get this over here in time. So there's our refresh, 2 seconds, and we get an impulse, so that pushed it in that direction. Let's push it down instead. So we'll push it 0 in the x and 100 down. And we go Control Enter. Okay, pushed it down, bounced off. Try it again. Boing. All right, let's move our ramp down a little bit so we can see that better. Here's our ramp. We'll move it 100. Oh, how'd that happen? 100 in the y from the center, and 100 from the x in the center. That's not what I wanted to do, is it? It's a good thing I did that. Let's move it down 200. So 200 down in the y from the center. Or we could have moved it up from the bottom. Can I get over here in time? Yeah, there we go. Okay, so we moved it down from the center a bit more, and now we can see our force pushing down. So the idea is we would want to We can make the ball easily use the keyboard to apply forces, because there's this thing called control. So you would just say ball dot control, and then as you use your keyboard, it would control the ball. Yay, much like the motion controller, but this is control for physics. So check that out. That's how we did that game when we were trying to turn off the computer chips and we followed the ball around or whatever. Remember that thing in our examples? But anyway, let's move to us applying a force with the mouse. So instead of doing the impulse on a timeout like that, we want to do it based on, well, let's just comment all that stuff out. Comment. We want to do it based on where the mouse is. So how about when we press? That would look like this. It would be a stage, or s dot on stage, oops, in quotes, stage mouse down. This would be anywhere on the stage. We might want to apply the force only when we press on the ball, or as we did in that kid's example, we made sort of an outer ring to it and only press on the outer ring, which was in the ball actually, so it turned out to be pressing on the ball. But let's just try it when we press on the stage. We will call this arrow function. Arrow function. Okay, and then what we'll do is we'll make it so that if we're farther away from the ball, the force is bigger. And if we're closer to the ball, the force is smaller. And that almost starts feeling a bit like a pool game. And we'll also make it go in the sort of away from where we pressed, kind of. Okay, so let's see if, let's just try it with the X to start. So we'll say circle dot impulse. And so here's the X amount. If we just said 100, then as soon as we press on the stage, it should have an impulse of 100. Let's have a look. Excuse me. Here it is. And I press on the stage. I press on the stage again. Okay, so every time I press on the stage, it's giving an impulse forward of 100. So it's not quite what we want. So we would want it so that it's something like the frames dot mouse x. So this will tell us where the frames mouse x is. Let's just try minus the circle dot x. So that's how far away these two things are. And then we want to probably multiply, that's just a distance how far away. We might want to multiply it by a factor of some sort. Let's try 20. I'm not sure. And let's just see what happens. So here I am. Whoa! Okay, first of all, it went the wrong way. So I pressed on this side, and it went backwards to the left. I want it to go away from my mouse. So we just switch these two. Yay. Isn't it nice? There's only two options there. I guessed wrong. I didn't really think about it. If I thought about it, maybe I would have figured it out. So ready? Good. Now that's pressing on the right direction. We'll see if we press on this side of it, it shoots the other way. Good. Okay. But, and what about how far away? If we're really far away, that almost looks less. If we're close, I don't know. I can't, oh, why? I can't tell the difference in the impulse, but I should be able to tell it by the difference here times the 20. Yeah, oh, okay, let's try just a little bit less, like times 2, and see if we can tell the difference. So there it is. When we're close, it's still going fairly fast, but if I'm far away, oh yeah, it definitely goes faster farther away, so let's just reduce it a bit more. Maybe we don't even need that. Maybe it's a decimal. And if I'm far, it's faster. If I'm close, it's little. Okay, not bad. There's a couple things we can do. We can adjust the friction of the whole place and see how that works. But friction will only work against objects. That's right. It doesn't work on the top view. So friction will work as it's sliding. Especially circles don't work very well with friction anyway. But if it were a rectangle sliding on this rectangle, friction then would work better. Otherwise, we're talking linear damping that we want to adjust. So that was just linear. So when we add the circle here, right here, there's the bounciness. We can also say linear colon 0.1 or something like that. Oh, I think that the higher, the more damping there is. So let's make it 1 and go Control Enter and have a look here. Yeah, see, it didn't even make it to the wall. So we've reduced how easily that glides, which is, I think, better for this exercise, so that as we're closer to it, we're moving slowly. That's not too bad. But let's get the Y going as well. So that's one thing, is linear. If we went 2, how is it working if we go 2? Let's have a look. Usually we think of 1. So almost stopping, isn't it? Like I'm just kind of nudging it along now. And even when it's a bigger force, it doesn't shoot very far before it stops. So you want to kind of balance that stuff. I think we're probably good back at 1. I think the default on it is 0.1. You want to see that just to remind you again? So here's 0.1. Oh, no, that's not default. That's hardly even stopping, isn't it? So that maybe 0.5, 0.7, 0.8, I don't know, something else is probably default. You can look it up in the docs. Still moving around. Okay, let's add the Y to it. So basically it will be this bit, I don't know, let's do something like const magnify equals 1, or maybe we'll make it 2. And so times the magnify, because you should have control over how much force there is, and that's a thing that we can balance, magnify. All right, the Y will be the same thing. Let's drop this down. Who's all sloppy? Oops. Magnify. Okay, I don't usually drop down parameters, but just so you can see those. But this will be the Y. I think it's probably based on the, well, I'm sure it's based on the Y. I think it's probably the same thing, where direction, and we'll use the same magnify. Okay, Control Enter. And now we should be able to push it along. Okay, so too much force. And a little bit too bouncy for, well, I don't know. It glides a bit too much for me. So that means, yes, we want that something like 0.8 in the linear. And our magnify, let's try 0.5. So this should be a little bit harder to push. Yeah, it is. It doesn't quite go as far, but the farther away we are, the more it pushes. And all of a sudden I feel like I'm playing pool, like I'm pulling this back and shooting. Boom! But if I wanted to do it further, I pull it back and shoot further. If I wanted to do it less, I go closer to it. Okay, isn't that wonderful? Now we didn't make this follow around the cursor, but I suppose you could. If you just wanted to follow the cursor, then you don't do it on stage mouse down, you do it on stage mouse move. And on stage mouse move, instead of pushing it away, if you wanted to follow it, whoa, okay, this is, I know what's going on. This is definitely pushing it away, but you see how much it's like, Well, do you know the difference? Stage mouse move is happening all the time. Therefore, you don't want, let's just back out of this and keep a copy of it. So this was one copy where it's working like so, and that seemed pretty good. And if I comment this out now, we don't want a impulse now, because stage mouse move, once we get move in there, happens all the time. As you're moving, it's sort of constantly triggering. Oh, I'm moving. So it's like a whole bunch of impulses is the wrong thing. We want force at that point. And this is pushing it away from where we are. Let's go Control Enter. So now I'm pushing it away. That's pretty cool though. It's like it's got some sort of aversion to me. So I'm pushing it away into corners. But I can also pull it towards me, which would be switching these two. So that goes back to how we had it when we had it wrong the last time. Okay, so if we want it to come towards us, we switch the direction here. And let's see what we get. Now it's, whoa, whoa. Yeah, it's coming there, but why doesn't, oh, it's because I haven't moved. Right, so if I wanted to work like an elastic, I have to kind of keep it moving, and then I go way over here and keep it moving, and it'll go wow, 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 because we're doing it on mouse move only. So that's not too bad. It's sort of trailing around, and you see how that now works with the physics stuff. It's like, come on! It's almost like dragging it, but we're not exactly. We're just winging it around. But if I don't move, it doesn't come at me. So we could do it in a ticker as well, rather than on the stage mouse move. You could just put this whole thing into a ticker. And so that would look like this. Ticker.add, round brackets, that stuff. And so instead of doing the mouse move, and now we go Control Enter. And the ticker is working all the time too. And now we're getting the wow, wow, wow. So now it keeps on trying to follow the mouse. Wow, wow, wow. We could knock things down with this. Oh, it's like we got a wrecking ball. The wrecking ball. But if we don't want it that sort of wow, wow, wow feel, then I guess what do we have to do? Decrease the, I don't know, what do you think? We could decrease the magnify, I suppose. 0.2. Might then follow it more slowly, but if we decrease the magnify and increase or decrease the linear damping, let's see what we got now. I think it's worse. Yeah, so what do we try to fix that? We decrease the magnify, so that means the force is less, but we've just made it too easy. So if we set this to 2, I don't know what will happen then. Okay, well, yeah, that's all right. It's just heading towards the cursor a little bit more slowly. So anyway, you just got to work out how you want to deal with it. I'm not sure if it's actually possible to get it perfect, but that's not too bad. Seems good. It's just getting there a little bit slowly. We would want the force to be bigger. So what if we have it a force of 1, but a force of 2? And then increase the linear damping to 5. Hey, yeah, there we go. Okay, so a bigger force to get there, but the linear damping is more. Okay. So there she'd be following it, and yet we can bounce off things, and there you go. We might want that only when, like right now I feel a bit claustrophobic. Maybe when we press down, have it follow it. But that's almost like a mouse joint at that point. Maybe you just want to use the mouse at that point. But there we go. We've seen a whole bunch of different things. Oh, sorry. I was so enthralled with that that I forgot to bring the thing. It's like, oh, there we go. So my apologies. Isn't that funny? I forgot to bring it over onto the other screen. And you're going, we can't see it. What does it look like? So there we go. I hope I brought the other examples over. So this was moving too slowly. I may have not. I don't know. Luckily, I've got them all still active here. This was too wow, wow, wow. This was worse. So that's with no linear damping. So we've increased the damping, and this is the last one where we increase the force and also increase the damping, and then you get that kind of effect. All right. Let's just take a quick review of that. We went through physics. You can adjust the gravity in here to 0 or to whatever you want. You can make things float up in the air by reversing the gravity, -10. There's also bounds. So we didn't show you the boundaries that we can put in there. You can stop them from bouncing. We didn't show you contact. Maybe good, possibly to do another tutorial on contact and a few other things like that in physics. Maybe why not? Or you can go out and take a look at there's a whole bunch of ZIM tutorials already on that, just not in Animate. We can add physics to any of the objects, so that could be a movie clip. If it's a movie clip, you want to make sure that you zimify the movie clip before you try and add physics, because it won't have add physics unless you zimify that movie clip. So see our second tutorial on zimify, and we've been zimifying some things as we go too. We can make various adjustments there to how we want it. And there we put a circle inside that one just so we could see the circle is spinning. Here we've got a rectangle that doesn't fall because we've set it to not be dynamic. And then we took a look at some other ways to add forces and talked about that. And there we ended up doing it in the ticker, but the stage mouse move would have been good too. All right, or clicking down, the stage mouse down, or clicking on the object. So you might want not to click everywhere, but just click on the object. I think you'll be able to work that out. If not, you can go see that kids tutorial. Why not, huh? So I am Dr. Abstract. This has been a ZIM tutorials for Adobe Animate. And remember that you got to bring in your ZIM shim with physics for the physics to work there. Normally we'd be bringing in our ZIM shim. And you're welcome to ask any questions, zimjs.com/discord, zimjs.com/slack. We'd love to see you there. Hopefully you enjoyed this tutorial on physics. There's lots more out there with the ZIM physics as well. Go to the Learn section, check things out. You might want to look at those Angry Birds tutorials. I think we did a Floppy Birds with, or Flappy Birds. Floppy or Flappy? Flappy Birds maybe with physics too, perhaps. All right, take it easy. Have a great day or night. Cheers.